Hello students, in this video we will talk about hypothesis testing regarding a parameter. First we're going to learn about the language of hypothesis testing. We will determine the null and alternative hypotheses, and then we will explain type 1 and type 2 error, state conclusions to hypothesis tests. First of all, the hypothesis is a statement regarding a characteristic of one or more populations. In this chapter, we will look at hypotheses regarding a single population parameter only. Examples of claims regarding a characteristic of a single population. In the year 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So please notice the language different today. The percentage is different today. That is an important language that we need to pay attention to. Let's look at a different example. Here's another example. According to a study published in March 2006, the mean length of a phone call on a cellular phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So again, notice here the language increased. So the claim here that the length of a phone call has increased versus in the old claim, the researcher believes that the percentage has changed or it is different today. Let's look at a third example. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes that the standard deviation has decreased. So here is another claim. The manager claims that the standard deviation has decreased. You notice in these examples, we have old study and we have old researches, and then we believe that the proportion or the mean or the standard deviation has changed. And that is what creates the hypothesis testing, because we need to test our claims if they are valid or not. You know that if we have the population data, we don't need inferential statistic. Usually when we have a claim that we want to prove, we're going to take a sample and then compute a parameter. And then based on the information we have, we're going to test our claim, whether the proportion, mean, or standard deviation from the old study is still valid or not, based on the decisions that we're going to make from hypothesis testing. If the population data is available, we don't need that process and we don't need the inferential statistics, because we can just come up with the parameter right away. Instead of saying the statistic that we calculate can be inferred into the entire population, we don't need to do that, and we can come up with the parameter right away for the population. Hypothesis testing is the procedure based on a sample evidence and probability used to test statements regarding a characteristic of one or more populations. In this chapter, we will only talk about one population. The steps to test our hypothesis: first, to make a statement regarding the nature of the population, which is the claim. And then after we have our claim, we're going to collect the evidence sample data to test the statement. And then we will analyze the data to assess the plausibility of the statement. And we will learn that step by step. The null hypothesis, we're going to use the notation H sub 0. I'm going to read it H naught. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. The null hypothesis usually comes from old researches that was done in the past, and we think the percentage or the mean or the standard deviation has changed. You will notice that I will be talking only about proportions or percentages and the mean. I am not going to talk about standard deviations in this chapter. The alternative hypothesis, we will use the notation H sub 1, is a statement that we are trying to find evidence to support. So that will be our claim, whether we claim that the parameter has increased or decreased, or it is different, or it's not the same. So all of those claims need to be tested, and this is exactly the alternative hypothesis. Sometimes you will see that we use the notation H sub A to indicate the alternative hypothesis. In this chapter, there are two ways to set up the null and alternative hypotheses. First, equal versus not equal hypothesis. That is the two-tailed test. Remember the first example that says, in the year 2009, 62% of American adults volunteered their time for charity work, and the researcher believes that this percentage is different today. So when we say it is different today, we suggest that the parameter is different. So it is not the same value, and that will create a two-tailed test. In other words, we can put it this way. We could say that the null hypothesis states that P is equal to 0.62 from that example. H1 states that P is not equal to 0.62. So from that example, we can write our null and alternative hypothesis like so. The second case is when we have equal versus less than left tail test. This is similar to the example of the wine that goes into the bottles and the standard deviation was 0.23, and the quality control manager believes that standard deviation has decreased. So we can rewrite it as H0 states that the standard deviation is equal to 0.23. This is from an old research. The quality manager believes that the standard deviation has decreased. So it's going to be a left tail test, and we will use less than. That is when we have the equal versus less than case, which is a left tail test. The third case, which is the last one, is when we have equal versus greater than. And this is the right tail test. For example, from 1996, the average phone call was 3.25 minutes. And a researcher believes that the average time for a phone call has increased. So we can write the null hypothesis as follows. We're going to say the mean is 3.25 minutes. And the researcher claims that the average time for the phone call has increased. And that is greater than, So this is greater than 3.25, and this is a right tail test. So basically, the null hypothesis will always have an equal sign, and then the alternative hypothesis depends on the language in the question. It's going to have either not equal sign or greater than or less than sign. And that is what I just explained. Then we will have 4 outcomes from hypothesis testing. The first outcome is to reject the null hypothesis when the alternative hypothesis is true, and this decision will be correct because we do have enough evidence to support our alternative hypothesis or claim, so we reject the null hypothesis. Next, we do not reject the null hypothesis when the null hypothesis is true, and that is also a correct decision because we don't have enough evidence to support the alternative hypothesis, so we don't reject the null hypothesis. The third decision is when we reject the null hypothesis when the null hypothesis is true, and this is called a type 1 error. And the last outcome is when we don't reject the null hypothesis when the alternative hypothesis is true. This decision is incorrect, and this is called type 2 error. The probability of making type 1 error, which is rejecting the null hypothesis when the null hypothesis is true, is called alpha. And the probability of making a type 2 error, which is not rejecting the null hypothesis when the alternative hypothesis is true, is called beta. The probability of making type 1 error, alpha, is chosen by the researcher before the sample data is collected. Usually, we will use a significance level of 5%, if not indicated in the question. So that is always the case. If alpha is not given, then we will choose alpha to be 5%. And that is a very common level of significance that's used widely. So when the probability of type 1 error increases, the probability of type 2 error decreases and vice versa. Another mistake that I want to make sure that you don't make is to use the wrong language. We never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated in the null hypothesis. Rather, we say that we do not reject the null hypothesis. This is just like the court system. We never declare the defendant innocent, but rather say that the defendant is not guilty. So how do we state our conclusion? Let's look at this example. According to a study published in March 2006, the mean length of a phone call on a cellular phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. Suppose that the sample evidence indicates that the null hypothesis should be rejected. How are we going to word the conclusion? And suppose that the sample evidence indicates that the null hypothesis should not be rejected. State the wording of the conclusion. So for the first one, when we suppose that the sample evidence indicates that the null hypothesis should be rejected, then we will say the statement in the alternative hypothesis that the mean call length is greater than 3.25 minutes. Since the null hypothesis is rejected, there is sufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. In other words, we support the alternative hypothesis because we rejected the null hypothesis. If the case is to not reject the null hypothesis, then we will say that since the null hypothesis is not rejected, there is not sufficient or there is insufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. In other words, the sample evidence is consistent with the mean call length equal to 3.25 minutes.